Right, welcome back to Mathematics. I believe you enjoy your break. We need to continue from where we stopped. Remember, we are still looking at logarithm of numbers by substitution, and we have solved about 3 examples. So we want to complete the remaining 2 in this particular episode. So let's begin. We have been able to look at question A, B, and what C, remaining D and what and E. So we need to solve D and E, and then we'll give you just 1 or 2 questions that you also need to solve, evaluation question that you need to actually use to evaluate yourself, assess yourself to know whether you understood what we have done so far. Okay, remember we have 4 steps that we have been taking in handling logarithm of numbers by substitution. So let's continue with the 4th question. Need for us to look at question D now. We have log 81 in this term. So how do we go about this question? How do we go about this question now? Remember the steps. Take note of the unknown logarithm. This is the unknown logarithm. Then take note of the known logarithm. These 2, they are known. Then using appropriate laws, express the logarithm of the unknown. The logarithm express the unknown logarithm in terms of the known word logarithm. So the unknown logarithm, we are going to express it in terms of the known logarithm. And yes, that's the log 81. But we have to remember that 2 cannot go in here. 2 is not a factor of 81. So 81 will be expressed in terms of 3 alone in this case, because we go like this, like we did when we handled 24. We have 27, 9, we have 3, and we have 1. So that's 3 raised to the power 4, 1, 2, 3, 4. So if we want to express 81 in terms of the known logarithm, although we know this and we know this, we are not going to use this because 2 is not a factor here. So if we are writing 81, now it's going to be log 3 raised to the power 4 in base 10. That's what we have. 3 raised to the power 4 in base 10. And once we do that, this 4 is preventing us from substitution. So we need to apply the 3rd law of logarithm to take the log, another part of the expression, and that's log 4 log 3 base 10. You still remember that particular law. Still remember it. You must remember laws. Very, very important. The same way people remember laws, you know the laws that you need to keep even in your school, and you remember them. You also remember the laws of logarithm. Failure to remember the laws of logarithm, you will commit mathematical offense in logarithm, and that means you are going to logarithm prison. They will imprison you in logarithm. That's true. That's why so many people will be solving a problem and they will get stuck at a particular point because there is a law they have failed to apply, or there is a step they have failed to apply. So they will enter into the prison of that particular topic, and they will just be running around. And that's when students become magicians. They will just do a lot of things. So students will just tell you 2x minus 1 equals 1 equals 4 equals x, and then finally x equals 1. You now say, what is the meaning of this? They just do a lot of magic. All their bradacabra, they will gather it and just invest it in that particular question in order to arrive at an answer. Well, mathematics is logical. If you are doing anything and it is not workable for all the questions, then it means you are a mathematician, not a mathematician. Yeah, there are many mathematicians. They are not mathematicians, but rather they are mathematicians. All right, back to what we are doing. We say that this is a stumbling block to the substitution we want to do. So we remembered our 3rd law and we used it to remove this. Now we can substitute. Log 3 is actually what? 0.4771. So this becomes 4 times 0.4771. This 4 multiplying this. The whole of this is this. So let's carry out the multiplication of the 0.4771 You know, these days, many students will just use calculator. Well, let's keep our calculator by the side. 4 times this is 4. 4 times 7, we still know is 28. We write down our 8. Take 2. 4 times this is still 28. When we add it to 2, is 30 that we're going to have remaining 3. 4 times this is 16. Plus that 3 will give us 19. We put down our 9. 4 times 0 is 0 plus 1. We have that. So this will give me 1.9081. That's log 81 in base 10. So log 81 in base 10 will give us that. Okay and okay. Okay and okay. Alright. We'll have one more question before we now give you the question that you need to solve. Just one more question before we give you the question that you need to solve. All the ones we have looked at, remember we said to split these numbers, we either use multiplication or we use division. And so far, we have looked at the cases where we use multiplication and also cases where we express these numbers in using index form. Now we have a particular question, question E. It's in decimal. This is 7.2. 7.2. How do we go about this? So let's follow our steps. Let's follow our steps. Okay. We have E log 7.2 in this term. Okay, what do? We have a decimal. Remember in our previous videos, there was one of the videos we made a very important point about decimals. We say we change them to what? To fraction, to vulgar fraction. And if I do that here, I'm going to have log 72 over 10 in this term. You remember 7.2? In mathematics, we say that a decimal place represents a 10. So this is 72 over 10 because we have one decimal place. If we have 0.72, we have 72 over 100 because the first decimal represents a 10, the next one represents a 10. So to remove this decimal, I need 2 tens that will multiply. I just need only 1 10 that will multiply to remove this one. So that's why we have 72 over 10. Okay, so we now move on. Now there is a mistake a student will just make. Let's see that mistake. Let's see that mistake. Okay, let's keep the mistake and just finish the problem. Then we'll revisit where the student would have made a lot of mistakes. Now, this is now in terms of division. Is there any law that can split this? The numbers I have are 2 and 3. Is there any law that can split this? Yes, there is. Let's first of all break it using the laws of logarithm. Log 72 over 10. Okay, let's use symbols first. In our law, we have that log m plus log n in this a is the same thing as what? Log. Sorry, it's subtraction now, the second log. Something as log m over n. This way. Now you look at this. Look at this. This and this are just the same. This is this. So this 72 is now m is this. Now, so this is already in this form. Remember, we are taking our steps. They say using appropriate laws of logarithm, express the unknown logarithm in terms of the known logarithm. So that's what we are trying to do here. That's what we are trying to do here. Express the known logarithm, the unknown logarithm in terms of the known logarithm. So using appropriate law. Which law can actually break this? This is the law. So this is already in this form. But leaving it in this form, we cannot solve problems. So what's the alternative form? This is the alternative form. So I need to use this law to express this particular expression now. I need to express this in terms of this second law. It's already in this form. When we are subtracting two logarithms of the same base, we use the second number to divide the first number. That's what is happening here. So I can break this down to log 72 minus log this in base 10, log 10 in base 10. Okay? Okay. Alright. We'll go further. We don't know log 72 here, so that we'll say we substitute. Log 10 in base 10, you remember the fourth law, so this one can reduce to 1. So this is not our problem. Where the issue lies is this: log 10 in base 10 is 1. Logarithm of a number to its own base is 1. So where the issue lies is on this. The logarithms that were given to us are logarithm of 2 and 3. So I need to break 72 down in terms of 2 and 3. Let's see what we are going to have. 72. 2 divide this is 36. 2 divide this will give us 18. 2 divide this is 9. 3 here is 3. 3 here is 1. So I have 2 raised to the power 3, and I have 3 raised to the power 2. So this and this, when I multiply this and this, I'm going to get 72. So what will I do? I will now write 72 as log 2 raised to the power 3 times 3 raised to the power 2, all in base 10, minus log 10 in base 10. Now, additional law will be applied though. What's that additional law? When these are multiplying, you remember that log m in base a plus log n in base a is log in base a, m times what? N. So we have this times this now in base a, in base 10. So I can take this, which is this now, back to this one. And when I do that, I'm going to have log 2 raised to the power 3 in base 10 plus log 3 raised to the power 2 in base 10 minus log 10 in base 10. Okay. We still have the stumbling block of 3 and then 2 here. So we'll write it using the third law now. 3 log 2 in base 10 plus 2 log 3 in base 10 minus log 10 in base 10. So we're almost through. We now have 3 times log 2 in base 10 was given to us as well 0.3010 plus log 3 in base 10 was given to us as well 0.4771. 2 times 0.4771 minus log 10 in base 10 will give us what? 1. Okay, I think we need to use this part of the board now. We can leave our steps. We can still clean it. So we're almost done on this. So if we multiply, let's carry out our multiplication here. 0.3010 times 3. This is 0, this is 3, this is 0, 9, and that's 0. So the whole of this now will become 0.9030 plus. What is this one? We do that multiplication 0.4771 times by 2. That is 2, which is 14 and 1. 2 times this is 14 plus 5, we have plus 1 is 15. 2 times this is 68 plus that, we have 9.0. So 0.9540. Take it again. 2 times this is 20. 2 times this is 14. Write 4, take 1. 2 times this is 14. Which one becomes 5? Take 1. 2 times 4 is 8 plus 1. To give us this. So we have 0.9542 minus 1. Minus 1. So if we evaluate this, 0.9030 plus 0.9542. If you add that, you have 2, 7, you have 5, you have 8, you have 1. So when you use 1.8572, that's when you add this and this, you have this. 1.8572. 0 plus this is this, 3 plus this is 7, 0 plus this is 5, 9 plus 9, 18, take 1 here. So when I use it to subtract 1, well, what will I have? I have 2, 7, 5, 8, 1 minus 1 is 0. So the whole of this reduces to 0.8572. 572. That's what it will reduce to. So anybody can now do this. Once you're able to arrive here, you have your calculator that you can use to punch that. Okay, so far so good. I believe you are enjoying the meal. You're enjoying the meal. We're going to give you just a few questions that you need to solve. That will go a long way in helping you to master this. So let's look at this. Let's look at this. So let's probably take away patient or take away patient. Okay. Given that, still our beautiful log 2 in this time is 0.3010. Log 3 in this time is 0.4771. And log 7 in this time will be 0.8451. You see, find here what are the things we are going to find. Log 0.49 in this time, log 28 in this time, I see log 84 in this time, and log 35 in this time. Okay. These are the questions that we need to look at using those known logarithms. Now here, before we now leave, we have obtained this answer. There would have been a serious problem if a student decided here to do log 72 over 10 in this term. And the person now says 2 divide this, we have 36, and 2 divide this 5. We'll have problem here. What will be the problem? The problem will be we don't know the logarithm of what? 5. So I have to leave it like this because I know that at the end of the day is in base 10. Log 10 in base 10 will give me 1. But if a student decides to divide this in that form, you now have log 36 minus log 5, all in base 10. So where are we going to get the logarithm of 5 that we are going to substitute? You see that? So that's what I have to do. So when you are trying to solve these problems, always be careful. Always be careful to know when to use a particular expression. Because if you express the unknown logarithm in terms of the logarithm of a number that was not given to you in the equation, then you run into difficulty. All right. This way we are going to draw the curtain on logarithm of numbers by substitution. Remember that we have other videos on logarithm starting from the beginning. Now the next video will be on the equations involving what? Logarithm. It's an important video that you must watch, because that's an important aspect that mainly exam bodies, they usually concentrate on that particular aspect. So make sure you watch that video on equations involving logarithm once the video is uploaded. Alright, till I come your way again, keep enjoying mathematics meal. A meal a day is important. Very, very important to your mathematical health. Very, very important to everything that has to do with mathematics. A meal from mathematics is very, very important. Go on and talk about mathematics meal. Go on and talk about mathematics. Go on and discuss mathematics. Go on and eat mathematics. Go on and work mathematically. Go on and do everything applying the principles of mathematics. I even pray that even in your dream, you also solve mathematics. Don't mind me. God bless you as you continue to watch our channel, and also as you continue to recommend other people to this channel. Amen. Bless.